Good morning, 11th grade students. I had a great report from your sub yesterday that things went pretty well. Thank you for helping her out with all the printing stuff and really just being generally helpful. That is good to hear. I'm hoping to be back tomorrow. I'm going to leave sometime around noon today and maybe arrive in Bradenton at 4 a.m. on Wednesday. Hopefully be at school on Wednesday exhausted, but nonetheless be there. And a couple of things. First thing, on Wednesday I'm going to collect Section Review 2.1 and possibly 2.2 if you get to that today. And I'm also going to collect Lab 2. The next thing is that if you did finish your lesson yesterday and we're able to get through the whole thing, you're going to be taking a quiz that counts, but if you didn't, you're going to be taking a quiz that does not count. So if you didn't finish your lesson yesterday and you're finishing it on Tuesday, you're finishing Monday's video on Tuesday, which is fine. Your quiz will not count. It'll just be something that'll be helpful for you. So you may pause this video and take the quiz at this point. It seems as if my software is being annoying. There it is. Alright. Good. Short chapter today. I don't want to overwhelm you, and I don't want to overwhelm myself either. And we're going to be talking about the properties and changes in matter. This is something you discussed in physical science, so it shouldn't be anything necessarily alarming to you. The first thing is that physical changes change physical properties. Chemical changes change chemical properties. And physical chemical properties are different. Physical properties, you're still dealing with the same stuff. So if I rip a loaf of bread apart, it's still bread, right? But if I set the bread on fire, that's a chemical property. It will not be bread after I set it on fire. It will be some lump of carbon. Evidence that a chemical change has occurred is a formation of a gas. If suddenly a gas is forming, particularly gas with heat, that's evidence of a chemical change. Formation of a precipitate. So when you mix two liquids together and all of a sudden it creates a solid, that's evidence of a chemical change. Liberation or absorption of heat, light, or some other energy. If all of a sudden this thing starts glowing, probably a chemical change or a distinct change in color. We're talking a different color. So if you mix maybe a Kool-Aid packet with water, the water is going to change color, but it's a physical change. You're just mixing those things together. But if you mix a blue Kool-Aid packet with clear water and it turns green, chemical change. That's something new. So physical chemical changes, be thinking in your notes with me as we go through these. This will be physical. It's still glass. This would be physical. It is still a popsicle. Now it's just frozen. Spoiling milk would be chemical. It is no longer milk. It is some bacteria-plagued, chunky, nasty stuff. Mowing the lawn, physical, still grass. Slicing bread, physical, still bread. Roasting marshmallow. If the marshmallow just gets warm, it'd be physical, but if it is roasting, whenever you roast something, it changes the chemical properties because there's a little bit of carbon-formed burning, so to speak, and that's chemical. Breaking an egg, physical. Exploding fireworks, very chemical. It is making loud pops and noises and showing out light. That's very much an evidence of chemical change. Mixing Kool-Aid packets with water, physical. You're just mixing two things together. Squeezing an orange, physical. Evaporating water, a lot of people would say chemical, but it's physical. It's still water, even if it's water vapor. Burning toast, You can smell the chemical change. Burning wood, chemical. Popping popcorn, I would argue chemical. Whenever there is a liberation of sound, typically it is a chemical change. I don't like this example of bleaching, coloring hair. Some say physical, some say chemical. I'm going to lean chemical here because the proteins in your hair are literally being messed up. And melting chocolate, that is physical. It is still chocolate, it's just now melted. And whenever you have a mixture, like let's say you have Kool-Aid and put the Kool-Aid in the water, there's 3 different ways to get the Kool-Aid out of the water to separate that physical mixture. And the most obvious of which is distillation. Works very well. You take the substance, you boil it, and then one substance boils quickly and the other substance doesn't. And so the water would boil and leave the Kool-Aid in the original packet, and or in the original container you had. And so what would happen is the water would go up this tube, would go through the water vapor, I should say, go up the tube, cool through the condenser, and then the water would go into the collection flask, and the Kool-Aid would be left here. Very easy way. Fractional crystallization causes the substance to crystallize, which would be possible with something like Kool-Aid, because it was originally a solid. And so it heats and then cools something very quickly and then takes the crystal out. That is possible to use on many things. And chromatography, you might see paper chromatography, is where a substance is placed really on a different solvent to allow something to dissolve through and something to stay. Sometimes it's placed on like a piece of paper, and then some stuff goes through the paper and other stuff does not. Probably the least effective method, but useful for some things. And that's where we will end today. I'm assuming you didn't get through Monday's lesson, so I'm hoping that you get through this whole thing and you're able to do Section Review 2.2, page 26, numbers 1 through 2, and application number 2, and that you can have that ready for tomorrow. I do have on the board to read and complete Lab 3. We're not going to complete Lab 3, but I would like you to read it so that we can complete it at some later time. Have a wonderful day, chemistry students, and I will hopefully, God willing, see you tomorrow.